Hi, so today we're going to be talking about how ACH or acetylcholine becomes a muscle contraction. So everything starts in action potential. The ACH travels down the motor neuron until it reaches the neuromuscular junction, where it signals an arrival and causes voltage-gated Ca2 plus or calcium channels in the nerve terminal to open. Once the calcium enters the neuron, it triggers the release of acetylcholine, ACH, into the synaptic cleft. The ACH then binds to an ACH-gated channel onto a muscle cell membrane. Once these open, it allows sodium ions, or Na, to flow to the muscle fibers. This creates local depolarization in the membrane. Once the depolarization reaches, it opens voltage-gated sodium channels to enter the muscle cell. The action potential membrane is then generated. This creates the spread across the muscle fibers, causing depolarization of the muscle membrane, and it travels through the T tubules. The action potential then signals the sarcoplasmic reticulum to release Ca ions into cytoplasm, causing tropomyosin to move from the binding sites onto the actin filaments. Then the myosin filament will attach to the binding sites on actin, forming cross bridges. The myosin head has ADP and phosphate that came from the ATP molecule. The phosphate is released and the myosin head performs a power stroke, which pulls the filament towards the center of the sarcomere, and this creates the sliding filament. During this process, the actin filaments move closer to the M line and the Z line at each end of the sarcomere and moves closer together. This shortens the muscle, producing a muscle contraction. Then after the power stroke, a new ATP molecule comes to the myosin head, and yeah, thank you.